Hi, let me welcome you for the lecture series which is on examples of interest and its factors. That is, some of the problems on various types of interest and its factors. Let us first directly go to the formulas which normally we use to calculate the different types of interest and different uh, types of the capital recovery or the different types of flows that you are having. Okay, so normally the type of flow, there are three types of flows that you have here in the interest formulas or interest section. Okay, the first one is a single type of flow. That is, under that there are two types of factors that we will be discussing. That is compound amount factor and the present worth factor. The compound amount factor, the notation that we normally use is f slash p comma I comma n. Here the f is to be found, p is the given, that is the principal amount is the given, and I is given and n is given. Okay, here in some of the books they use capital N and some of the books they use small n for the time period. That is, what is the time period for which you have to calculate the interest or calculate the amount. Okay, so the formula which is used for it, this we have already seen. That is, the future amount is f is equal to the principal amount, that is present amount, into 1 plus I to the power of capital N. Whether it is a capital N or small n, I will be saying only n here. Always the n represents the time period which you have. Okay, so it is the next, under the single payment series, you have the present worth factor. The present worth factor, we will be calculating the present worth of the future amount. Okay, that is the future amount, maybe I need around 1 lakh after 10 years. Okay, what is the value of that presently with the given interest rate and the time period. Okay, so the formula which is used here is p is equal to f into 1 plus I to the power of minus n, or it is f into 1 over 1 plus I to the power of n. We will be using the formula here. And the second type that you have is the equal payment series. Under the equal payment series, as you can see, there are 4 different types that you have. That is a compound amount factor, sinking fund factor, present worth factor, and the capital recovery. There are 4 types that you have here. So the first one, let us see. Let us discuss about the first one. The first one says it is under the compound amount factor. It is we have to find the future amount given the A, that is the equal amount. A is called the equal amount. That means every time period it is 1000 rupees every year or 1000 rupees every month it will be given. So that is the equal amount will be given there, and from that we have to calculate the future amount. Okay, it is going back, so it is going to the next slide. Sorry. So here we are calculating the f bar a comma I comma n. The formula which is used for that is f is equal to a into 1 plus I to the power of n minus 1 divided by I. Sinking fund factor. Under the sinking fund factor, we are calculating the annual equivalent amount of the future sum, that is f comma I comma n. The given here is f, I and n are given here, and we have to calculate the A, that is the equal payment that has to be done every year, that has to be calculated. The formula which is used for that is A is equal to, that is the equivalent amount is equal to the future amount f into I divided by 1 plus I to the power of n minus 1 is a formula which we will be using here. These two are called where the future amount and the equivalent payment series are involved. Okay. Next two is the present worth factor and the capital recovery factor. Under the present worth factor, the P is calculated, that is the present actually today the amount is calculated by knowing the equal payment series, that is A comma I comma N, that is interest rate and the number of time period is given. Okay, where P is equal to, the formula used for that is equal to P is equal to A into 1 plus I to the power of N minus 1 divided by I into 1 plus I to the power of N. Next is the capital recovery. Under the capital recovery, we denote it as A by P, that is the equal payment series, by knowing the present value and the interest rate and the future time period, that is PIN is known and we have to calculate the A. Okay, the formula used for that is A is equal to P into I into 1 plus I to the power of N divided by 1 plus I to the power of N minus 1 is the formula which is used. And the last type that you have is the gradient series. That means here the uniform amount is not there. There is a change in the amount that you are depositing or the change in the amount that you are receiving it over a period of time. That is what is nothing but a gradient series. Under this there are two types. That is the first one is the linear gradient present worth amount, and that which is denoted as P by G comma I comma N. That is the present worth will be calculated by knowing the gradient series G comma I comma N. That is, G is the amount of gradients that is going to happen from the first year to the second year. How much of gradient will happen? If first year if I pay 1000 rupees and if the next year if I pay 1100 rupees, that extra 100 rupees is called G, and from then onwards we will be paying 100 rupees extra every year. That is what is nothing but a gradient pay, which will be calculated or which is given here, and P will be calculated, the present worth factor will be calculated there. Okay, so the P is equal to G into 1 plus I to the power of N minus I N minus 1 divided by I squared into 1 plus I to the power of N. This is the formula which we will be normally using it. Okay, then the last one you have is the linear grade annual worth method. Since he has given it as an annual worth, A is being given, A has to be calculated with the given gradient pay, that is how much gradient it is happening every time period, and I, that is the interest rate, and the N, that is the time period for which the gradient series has to be calculated. By giving GIN, we have to calculate the A, that is annual worth amount we have to calculate. Okay, you may be seeing that all these formulas, whether we have to buy out all these formulas and use the formulas in doing the calculation. Okay, there is no need of by hearting all these formulas. If you know it, it is better to use it and apply it, but these are all the formulas which is being used and calculated, and it is being given in the table. Okay, that is the interest table is being given. From the interest table you have to find out with respect to the N and with respect to the interest rate. Okay, we have to find out the value of that and then put it into our and substitute in our problem and calculate the amount. That is what is the method that we will be using it. Okay, now let us see the first one, that is the single type. That is, the type is the single payment series. The compound amount factor we will see. Okay, so single payment compound amount factor, what this we have already discussed once in the last video. Again I will be refreshing that, or again I will be rebrushing those things here. Okay, here the objective is to find the single future sum F, that is one amount, that is after 10 years what is the amount that I am going to get if I deposit 10,000 rupees now at a bank at an interest rate of 10%, 20% at something. Okay, if the initial payment P made at the time 0 after n period at an interest rate of I, that is monthly or yearly interest rate is with that traced compounded every time period, that is every time period it is being compounded. The cash flow diagram for this particular method is given here. As you can see, the cash flow diagram, which shows that there is a sum which is being given here, that is a P, which is given at the initial time period as 0, and there is an interest rate, that is I, is being given there, and over a period of time, what is the future amount that I am going to get. The formula which is being used here, I have already said the formula there. The F is equal to P into 1 plus I to the power of N. It is represented as P into F bar P comma I comma N, where F bar P comma I comma N is the single payment compound amount factor that we will be using it. Let us see one example, or let us take one problem and see how exactly you are going to calculate this. A person deposits an amount of 20,000 rupees at the interest rate of 18% compounded annually for 10 years. Find the maturity value after 10 years. This is a very simple problem, and it is a straightforward problem. What is given there is P is 20,000 rupees. That means today you are investing 20,000 rupees in a bank or depositing in a bank, and the interest rate that the bank is giving is 18% compounded annually, and the time period N is 10 years. Okay, PIN is being given. The formula which is used is F is equal to P into 1 plus I to the power of N. That's what I said. It is either it is a small n or capital N. It is one and the same. It is the time period. It is represented as F is equal to P into F bar P comma I comma N. Okay, this is the representation that we do it. And for the future sum, that is after 10 years, future sum after 10 years is equal to 20,000 is the principal amount, F bar P that we have to calculate, comma I, we know that is 18%, and N is 10 years. Next, 20,000 into 5.234. Here, how did you get this particular 5.234? 5.234 you have taken from the table. Okay, you have taken from the table. How you have taken it from the table? This is the table that you have. If you can see the compound interest table, it is given that from the 0.25% to 60% he has given. That you can see it here on the top. That is percentage he has given here. That is from 0.25% to 60% table is available. You have to go to the respective percentage table. So directly go to the 18% table, and in the 18% table, the other factor that you have to see is here the single payment series, the uniform payment series, or the arithmetic gradient factor that he has given. Now we are calculating is the single payment series. Out of that, there are two types that you have, that is compound amount factor with the find the F given the P. Okay, sorry, let us move to the next slide. So find the F given the P. Okay, that means you have to F bar P has to be calculated. For that, you have to calculate the N, that is number of time period. Here he has given the number of time periods, that is first year, second year, third year, fourth year, fifth year. For every 5 years there is a line which is shown there. Okay, so we have to go for the time period 10. That means as per the problem, he says it is 10-year time period is being given. So the 10-year time period, and if you take the F bar P, it is 5.234. Okay, that value is taken here. That is 5.234 multiplied by 20,000. You will get 1,04,680 rupees at the end of 10th year. If you deposit an amount of 20,000 rupees now with an interest rate of 18% for the 10 years period. Fine. Now let us go to the next type that you have. Okay. I hope this you understood the how do you read the table. Again, once again, we will take up to the next problem and we will try to discuss there also. It is a single payment present worth amount that we will be calculating here. That is the second type that you have. In the second type, here the objective is to find the present worth. That is, here we have to find the P. But we know the F, that is the future sum we know. That means after 10 years I will get 10 lakh rupees. What is the present value of that money? That we will be calculating. So we will be knowing the N, that is time period. We will be knowing the interest rate compounded annually, that will be calculated here. The corresponding cash flow diagram is shown in the figure here. Here the F is being given here. That is P we have to calculate. F is given with an interest rate I and also the time period N. The formula that we are using here is formula P is equal to F into F divided by 1 plus I to the power of N. We represent this as P by F comma I comma N because we have to calculate the P. Given is F I N is given here. Fine. That is future amount, the interest rate and the time period is given. With that, we will be calculating the present amount. Let us take a problem and discuss that. So, the example 1.2, as you can see there, a person wishes to have a future sum of 1 lakh rupees for his son's education after 10 years from now. What is the single payment that he should deposit now so that he gets the desired amount after 10 years? The bank gives 15% interest rate compounded annually. What is the data that is being given? The data that he has given, future amount, that is after 10 years I need 1 lakh rupees. The interest rate is 15%. It is compounded annually he has given, and the time period N is being given. What we have to calculate is P here. P is equal to F divided by 1 plus I to the power of N is the formula that we are using it. It is denoted as F into P bar F comma I comma N, where F is a future amount, that is 1 lakh, it is being given. P bar F comma I is also given, that is 15%, and N is also given 10%. So with this, let us go to the table, and for the 15% and for the time period 10 years with P bar F. Sorry, here. If you can see the P bar F here, that is the table, if you can see the P bar F, the single payment series, P bar F 15% and N is 10 years, it is 0.2472. This we have to take it and we have to substitute here. That is 1 lakh into 0.2472. It is 24,720 rupees. That means we have to deposit 24,720 rupees now to get an amount of 1 lakh rupees after 10 years with a 15% interest given by the bank by compounded annually. Right? Now let us go to the third type of series that you are having, that is equal payment series compound amount factor. The equal payment series means every time equally that amount has to be paid in series. That means from the day 1 to the day last, that is till the nth period. It is a type of investment mode. The objective is to find the future worth, that is N equivalent payments, which are to be made at the end of every interest period till the end of nth interest period at an interest rate of I compounded at the end of each interest period. That means the compounding is at the end of every each interest period, that is 1 year it may be. Okay, the corresponding cash flow diagram is as shown below. As you can see here in the cash flow diagram, from the 0th year there is no investment which is at the 0th year. First year we are investing some amount. The amount which you are investing on the first year, second year, third year, fourth year is equal. There is no change in the amount A that you are depositing. A is the amount that you are depositing every year or every month, whatever may be the time period that is being given. With an interest rate, some interest rate is being given there, and what is the future amount that I am going to get. That means here F and A both is being given. That is, even on the last month you have to deposit the amount and then take the future amount. That is what it says, right? Let us say what is the each and every notation that I have already said. A is the equal amount deposited at the end of interest period. That is, at the end of interest period means first year. That is 0th year to first year you will be paying it. Okay. N is the number of interest period, I is the interest rate, F is the future amount. The formula which is used to find the F is equal to A into 1 plus I to the power of N minus 1 divided by I is the notation, that is the formula that we use. The notation that we are using for this is F is equal to A into F by A comma I comma N. That is future amount with annual the equal payment series A with an interest rate and with the time period. F bar A comma I comma N is termed as equal payment series compound amount factor. Let us take an example and see how exactly that we will be calculating here. A person who is now 35 years old is planning for his retired life. He plans to invest an equal amount of 10,000 rupees at the end of every year for the next 25 years, starting from the end of the next year. That means not from the 0th year, at the end of first year he is putting that particular amount. The bank gives 20% interest rate compounded annually. Find the maturity value when he gets retired. That means at the age of 60, how much he is going to get the money. The data that is being given, A is 10,000 rupees that he is putting every year. N is equal to 25 year. Be careful, don't get confused with the N is equal to 35 years. A person is old by 35 years. Okay. Some of the students in the examination we have seen 35 years. Yes, they have taken blindly 35 years and they have calculated. But the person age is 35. But he is putting for 25 years, or he is saving that particular amount for next 25 years. I is equal to 20%. F is equal to how much? Let us see the cash flow diagram for this. Okay. The cash flow diagram says 0th year he is not putting any amount. At the end of first year he is investing 10,000 rupees in the bank. For the next 25 years he is investing 10,000 rupees with an interest rate of 20%. What is the future amount that he is going to get? The formula which we can use, F is equal to A into 1 plus I to the power of N minus 1 divided by I. It is can also be represented as A is equal to F by A comma I comma N, where A is given, that is 10,000 rupees. F by A comma I is known, that is 10%, he is 20% is giving the interest rate, and N also is known for you, that is he is doing it for 25 years, he is saving for 25 years. Then from the table you have to go to the F bar A table for 20 years and 25 years and 20%. Okay, let us go to the table and see what has been given here. This is the table that you can see here. This is a 20% interest rate. Okay, first you have to take up this 20% interest rate, and then what we have to calculate is F by A, that is future amount of a given A, that is A is given as 10,000 every year. Okay, so that F bar A, we have to go to this particular column. For what is the year that he is saving? He is saving for 25 years. It is 471.981. This we have to take it and then we have to substitute here. 471.981. If you multiply 1000 into 471.981, you will get 47,19,810 rupees after 25 years. If you deposit 10,000 rupees every year with a interest rate of 20% for the next 25 years. Right? Let us go to the next type of series that you have. It is a equal payment series sinking fund method. Okay, here it says sinking fund. Why it is called as sinking fund means every time you are putting that particular amount. Okay, in this type of investment mode, the objective is to find the equivalent amount A, that is how much is going to sink. A we have to calculate. Okay, that should be deposited at the end of every interest period for n number of interest period to realize the future sum, that is how many interest period to get something around 10 lakh rupees after 10 years. How much I have to pay now? That is what we have to calculate here by knowing the interest rate I. The cash flow diagram for this is, as you can see in the cash flow diagram, we have to calculate this A here. What is given? I is given here, F is given here, and N is given here. By knowing the N, F and I, we have to calculate the A, that is the equivalent amount that we have to deposit every year to get a future sum of some amount. Okay, fine. Where A of F comma I comma N is the notation that we can able to use it for sinking fund method. That is, A has to be calculated by knowing the future sum, interest rate and the time period. The formula which can be used is A is equal to F into I divided by 1 plus I to the power of N minus 1, and where A is the equivalent amount of time deposited amount that we have to deposit equally. N is the number of interest period, I is the interest rate, F is the future sum amount at the end of nth period, and the formula which is used is to find the A. A is equal to, sorry, there is a mistake here, this is supposed to be A. Okay, A is equal to F into I divided by 1 plus I to the power of N minus 1. Let us take a problem and see how exactly we have to calculate in this particular example. A company has to replace a present facility. That means there is a machinery which I have to replace it after 15 years at an outlay of 5 lakh rupees. That means during that particular time period, the cost of the machine will be 5 lakhs. Outlay means the money which you are giving for the machinery is 5 lakh rupees. That is, F is 5 lakh rupees. It plans to deposit an equal amount at the end of every year for the next 15 years. That means we have to plan for A. How much we have to plan for A? For the next 15 years. That is, N is equal to 5 at an interest rate of 18%. That is 18%. I is equal to 18% compounded annually. Find the equivalent amount that must be deposited at the end of every year for the next 15 years. The given F is equal to 5 lakh rupees, N is equal to 15 years, I is equal to 18%. We have to calculate A. The cash flow diagram for this is, we have to calculate the A here. The given is I is equal to 18% and 5 lakh rupees I need it at the end of 15 years. The formula that I can use here is A is equal to F into I divided by 1 plus I to the power of N minus 1. where it can also be represented as A is equal to F into A by F comma I comma N. That is, A we have to calculate, F we know, I we know, and N we know. Okay, F is 5 lakh rupees that we need, and A bar F comma I is 18% and 15 years is the ratio. The value that you get it from the table is 0.0164 multiplied by 5 lakhs. The amount that you have to deposit every year is 8,200. Sorry, 8,200 rupees has to be invested every year for the next 15 years to get 5 lakh rupees. Okay, how did you get this 0.0164? That you can see from this particular table. Okay, if you see the table, you go for the 18% and you go for the sinking fund factor. That is, where in the sinking fund factor you have to find A given F. F is 5 lakh rupees in this particular problem. A bar F we have to calculate for the 15 years. N is equal to 15 years. So if you come to that 15 years, the value that you have is 0.0164. 0.0164. This is the value that we have taken. Multiplied by the 5 lakh rupees, you will get 8,200 rupees that you have to deposit every year for the next 15 years with an interest rate of 18% to get an amount of 5 lakh rupees. Right? We will go for the fifth one, that is equal payment series present worth factor. Okay, this is the, till now we have discussed about the annual factor. Now we will discuss about the present worth factor. The objective of this mode of investment is to find the present worth of an equal payment mode at the end of every interest period for n number of interest periods at an interest rate of I. Sorry, this is a small I which you have here. Okay, they have written it as capital I. There is a typographical error. Compounded at the end of every interest period. The corresponding cash flow diagram is as below. That means you have to calculate the present factor, that is P we have to calculate by knowing the A, that is how much every year we have to say, by knowing the I, by knowing the N. Okay, interest amount, interest factor also we know, and the time period also we know. What is the value of that particular amount to the present day, that we have to calculate here. Here P is the present worth, A is the annual equivalent payment, I is the interest rate, N is the number of interest period. The formula for to compute the P is P is equal to A into 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n. This is just a formula that we are using it, but we don't, you can calculate using the formula also. If you are investor, if you apply the formula and if you calculate, you will get the same value, where P of A, P by A comma I comma N is the notation that we can use to calculate the equivalent payment series present worth factor. Let us take an example. A company wants to set up a reserve, that is set up a reserve which will help the company to have an equal amount of 10 lakh rupees for the next 20 years towards its employees welfare measure. That means annual amount that the company is keeping aside or reserving it is 10 lakh rupees for the next 20 years for the employee welfare measure, either towards his PF or towards his layout planning, or to give some welfare whenever some casualties happen in the organization. For that they are keeping that 10 lakh rupees every year aside. Okay, the revise it's assumed to grow at an interest rate of 15% annually. Find the single payment that must be made now as the reserve amount. to get this particular equivalent amount, what is the amount that I have to keep it now in the bank, so that every year I can get an amount of 10 lakh rupees for the next 20 years with an interest rate of 15%. That is what is the problem is. Okay. The data that has been given here, A is equal to 10 lakh rupees, I is 15%, N is 20 years. What is the P? That is the present amount that I have to keep it in bank. As shown in the above the present the cash flow diagram, that you can see the cash flow diagram here. The present amount is how much? If you need to get a 10 lakh rupees for the next 20 years with an interest rate of 15%. P is equal to 10,000 rupees into P bar A comma I comma N. Okay, P bar A comma I is 15% and N is 20. So if you go to the table and if you take the P bar A and 15% and 20%, if you check, you will get the value as 6.259. That is 15%. Okay, N value is 20 and the factor that we have to take is P bar A. That is the present amount with the annual amount, equivalent amount which is being given. 6.259 is the value that you have. 6.2593 I have taken. This is some other table that I might have referred where the fourth digit is being given. You can take 3 digits, that's more than sufficient. That is 6.259 can be taken. That is multiplied with that. You will get 62,59,300 rupees that you have to keep it in a bank. Presently, if you keep an amount of 62,59,300 rupees in the bank will give you 10 lakh rupees every year for the next 20 years with an interest rate of 15%. Right? There is one more mistake here. 62,59,030 I have put here. It is 300. Okay. So there is a small typographical error which you can see here. Fine. Next is the sixth type of series that we are seeing here. Here it is also an equal payment series. Capital recovery amount, he says. That is how much of capital recovery that we can able to do it. The statement goes like this. The objective of this mode of investment is to find the annual equivalent amount. That is A. How much we are going to get, the A we will be calculating here, which is to be recovered at the end of every interest period for N interest period for a loan P. That means I have given the amount now. I have given 10 lakh rupees for you. Every month how much you have to pay as an equal payment series, which is sanctioned now at the interest rate of I%. That is with some interest rate compounded at the end of every interest period. The cash flow diagram you can see here. Presently this value is known for us, or he is going to sanction this particular amount P, and we have to recover, we have to repay back this annual amount with a known interest rate and with a known time period. Okay, A we have to calculate here. P is given, I is given and N is given, and we have to calculate A here. Okay, the P is the present worth, A is the annual equivalent amount, I is the interest rate, N is the number of interest period. The formula which is used to calculate the A, sorry, there is also once again there is a mistake here. It is not the P, it is the A which has to be calculated here. A is equal to P into I into 1 plus I to the power of N divided by 1 plus I to the power of N minus 1 is the formula that we will be using here. Let us take an example to calculate A to find the P with P. Sorry. So here we use the notation as A bar P, because A has to be calculated, P is known. Okay, I is known and N is known, or it is given. Okay, so A bar P comma I comma N is the equal payment series capital recovery factor that we can use it. Let us take an example. A bank gives a loan to a company to purchase an equipment worth of 10 lakh rupees at an interest rate of 18% compounded annually. Its amount should be repaid in 15 years. Okay, the amount of 10 lakh rupees has to be repaid in 15 years with an interest rate of 18%. What is the installment that he has to pay? That is, every month how much he has to pay to the bank. The data, P is 10 lakh rupees. Okay, I is equal to 18% and N is equal to 15 years. A is equal to how much? The cash flow diagram of equal payment series capital recovery amount is as shown above. That is, 10 lakh rupees is being sanctioned from the company or from the bank. Okay, what is the annual payment that the company has to pay for the 15 years at an interest rate of 18%. Okay, so A is equal to 10 lakh rupees into A bar P comma I comma N, that is, I is 18% and N is 15 years. So if you go to the A bar P comma I comma N, that is 18 and 15 years, that is 18% interest rate and 15 years for a factor, that is A bar P. That is, A we have to calculate given the P, that is initial amount is being sanctioned, and the equal amount that has to be paid has to be taken. If you take this particular thing, the amount is 0.1964. This we have taken here, 0.1964 multiplied by 10 lakh is 1,96,400. So we have to pay every month 1,96,400 to compensation with respect to the amount that is being paid, to liquidate the amount or to give the whatever the loan which is being given, you can able to complete it by paying 1,96,400 rupees every year for the next 15 years with an interest rate of 18%. Right? Next we will see the uniform gradient series annual equivalent amount. Okay. So here in the uniform gradient series, we will be calculating the gradient that you have. Let us see that the objective of this mode of investment is to find the annual equivalent amount of series. Here also the annual equivalent amount will be calculated, but it will not be the same. There is a gradient, that is, from the first year to the second year there is slightly increase in the amount, or there may be a decrease in the amount. Both way it is possible. Okay, so there is a gradient which is happening, that is, there is an either increasing gradient or a decreasing gradient. There can be any type that is possible here. That is find the annual equivalent amount of a series with an amount of A1 at the end of the first year and with an equal increment. That is what we call it as G. Whatever the increment that is happening with respect to the first year to the second year, okay, that we call it as a G. And we always say G1, 1G, 2G, 3G, because first year it is 1 gradient, second year it is 2 gradient, third year it is 3 gradient for the A1, that is the initial amount that you are going to pay. For the following n-1 years with an interest rate of I compounded annually. Let us see the uniform gradient series cash flow diagram here. As you can see in the cash flow diagram, this is the A1, that is the first year. This is the amount that is being paid. A1 is the first year. sorry, there is a missing here, A1 plus 1G here. Then A1 plus 2G, A1 plus 3G, like that it goes on up to the 10th year. If it is 10th year, it is A1 plus 9G. That is N minus 1G. 9G you will be having here, because till that we have to pay the gradient. There is an increasing gradient that you have. If it is a A1 minus 1G, minus 2G, minus 3G, that means it is a decreasing gradient. That is, the first one, A1 will be up to here. That is the amount that you have to pay. It goes on decreasing over a period of, it goes on decreasing like this. It comes to the 0 here, or it comes to the A1 here at the last. Fine. Compute A under this section is A is equal to G into 1 plus I to the power of N minus I, N minus 1 divided by I into 1 plus I to the power of N minus 1. You can calculate by, because you know the G, you know I, you know N. You can apply and you can calculate. But normally we are going to see the table, that is where A bar G comma I comma N table, that is A bar G table, we will be seeing the value and then we will be substituting that value to find the final amount. Let us take an example here. A person is planning for his retired life. He has 10 more years of service, that is N is equal to 10. He would like to deposit 20% of his salary, which is 4,000. Don't get confused here. 20% of the salary is not the interest rate. It is a 20% of the salary that he is getting. That is 4,000 rupees. Okay. He is investing 4,000 rupees at the end of the first year, and after that, that is thereafter, he wishes to deposit an amount with an annual increase. That means every year he will get an increment. That increment amount he wanted to save and he want to put it into the bank so that he can able to take the retirement benefit. Okay. The annual increment that he is getting is rupees 500 for the next 9 years with an interest rate of 15%. The interest rate is 15%, not 20%. Okay. The 20% is the amount that he is depositing. Okay. Find the annual amount at the end of 10th year of the above series. Okay. What is the data which is being given? A1 he has given, that means his salary, from his salary he is saving around 4,000 rupees. G he has given, that means after that the gradient series is nothing but 500 rupees he is investing, and I is given, that is 15%. N is given, that is 10 years. Calculate the A, calculate the F. Fine. A is the equal gradient series that we are going to pay, and after his retirement, what is the amount that he is going to get? That means A and F we have to calculate. Let us calculate A first. Okay. A is equal to A1 plus, that is the A1 is the initial amount that he is paying, A1 plus G into A by G comma I comma N, that is equivalent gradient payment that he is going to pay. G is 500, that is given. A bar G comma I is 15% and N is 10%. If you go to the table of 15% and for the 10 years with the A by G, the value will be 3.3832 is the value that you multiply with the 500, you will get, that will be added to the initial amount, that is the A that he is paying. That is A is equal to, instead of 4,000 rupees he is paying 5,691 rupees 60 paisa every month for his retirement life. Okay. With the A we have to calculate the F. Okay. This is the equivalent to the paying an equivalent amount of 5,691 rupees at the end of every year for the next 10 years. The future worth sum of this revised series at the end of 10th year is obtained as follows. That is F we have to calculate. F is equal to A into F comma F bar A comma I comma N. That is future amount we have to calculate. We know the A. That is F by A is the formula that we can able to use here. The future amount is F. The annual amount that we are paying is 5,691 rupees 60 paisa, that we have to take it, and F bar A comma 15 comma 10. Okay, F bar A for a 15 comma 10 is the value for this from the table is 20.304. If you multiply this, the future amount that he is going to get is 1,15,562 rupees 25 paisa. That means the after his retirement, that is after the 10 years of his work life, when he retires, he will get an amount of 1,15,562 rupees 25 paisa. If he has saved 4,000 rupees in the first year, and subsequently 500 rupees he has added to his account. Okay. This is the table that you can see. First, initially we have taken the A bar G value. That is, whenever you take the A bar G value for 10 years, it is 3.383 is the value that you have taken. And if you take the F bar A, it is 20.304 that you have taken. See here, you have taken the 20.304 for F bar A, and if it is A bar G, you have taken 3.383 the value. Okay. So we have covered almost all the types of series here. So I thank all of you for watching this particular video. Thank you.